Math 1314, Tyler Junior College, Section 2.3, Linear Functions and Slope. The big picture. There's really not any new content in this video. Not watching it would not take away from what you've learned. But watching it might enhance how you see, well, the big picture. We've done all sorts of things with lines. We built equations, we took equations and got information from them, we graphed equations, etc., etc. So you can think of the equations we've seen from three different perspectives. Or the lines we've seen, I should say. Perspective one, we've looked at them as equations. And we had three forms of equations: point-slope form, slope-intercept form, and general form. And by the way, those are not the only forms, but they're the only forms that we're going to be studying. We've talked about equations from a description perspective, descriptively. Now, how can you describe a line? Well, I can give you 2 points. I can give you a point and a slope. I can tell you if they are horizontal or vertical. And there's even more things that we haven't gotten to yet, so we'll just do question mark here. And of course, we have the visual representation of a line, a graph. So what's the big picture? The big picture is, if you think of these as collections, what we've essentially done is gone from circle to circle. For example, when we took a point and a slope and made an equation, we went from here to here. Or if we took slope-intercept form and turned it into a graph, we went from here to here. Now, could we go from a graph to a description? Of course we could. Here's a graph, name a couple of points on it, go calculate its slope. And that being said, we could also turn a graph back into an equation by extracting information from the graph and building the equation from it. And honestly, any arrow from one circle to another is fair game. If I give you an equation in general form, I can ask you, what's its slope? What are its intercepts? Hey, we can list that over here, intercepts. Or I could give you a description of a graph and just ask you to draw it without coming up with the equation. That's pretty easy. Here's 2 intercepts, draw the graph. Okay, dot, dot, connect. Or here's a point and here's a slope. Or here's a horizontal line and its intercept. So the big picture is you can view lines in any of these capacities as an equation, descriptively, and graphically. And it's fair game to go between any two in any direction. So if you really want to expand your horizons, I challenge you, even if not prompted in a homework question or a test question, to see if you can pull off all 6 directions. Take an equation, turn it into a graph. That happens quite often. But can you take a graph and retrofit it back into an equation? Yes, but you'll probably have to pull off some descriptive information about it in order to build the equation. For example, looking at a graph and say, there's its intercept, I calculated its slope, now I'm going to build an equation out of it. But that's kind of, in my opinion, the big picture about all these problems that we're doing. Being able to fluidly go back and forth between the description of a line, the equation of a line, and the graph of a line. Now, there are more circles we could put here, like an application circle, but I think this is sufficient for now.